Okay, here we go. We're going to learn about electricity and electronics in this course. And to do this, we are going to actually manipulate electricity and make components do things. To do this, we have to use the Raspberry Pi. In the beginning of the course, when we are learning basic electronics concepts, we're basically going to use the Raspberry Pi as a simple power source. But as you learn to program, you'll actually be able to manipulate that power source and make it do different things, and actually even receive information by receiving electricity into the device. So today, for this quick overview, we're going to look at the Raspberry Pi. We're going to look at this card that has the explanation of the Raspberry Pi pinout. We're going to use some basic electronics components: a 220 ohm resistor, a blue light emitting diode or LED, a couple wires, and a solderless breadboard. All of these components will be used quite extensively throughout the course, and we'll get to them in a minute. In addition, you should also get out your power source for your Raspberry Pi. It looks like this. It has an AC wall plug to go into your outlet, and it has a micro USB. It may or may not have a switch on it. This one doesn't have a switch. It's perfectly fine to use one without a switch. It's just a matter of convenience. Rather than plugging and unplugging, you can just turn it off with a switch. Anyway, we're going to set these components aside for a few minutes. We're going to focus on these two, and I'm going to zoom in on these two components because they're really, these two items, because they're really what we want to think about today. Adjust the light a little bit. So, what is this thing? This is a Raspberry Pi board. It is a tiny computer. If we look at it, we can see that it's got a lot of things like a computer on it. Like on this side over here, if we turn it this way, we can see we've got a power source here. We've got an HDMI connection, like what you would use to connect to a monitor. We've got an audio jack. Keep going. We've got an Ethernet connection here. We've got 4 USB connectors. And then we've got a couple other components like a video output and a camera module, which in this course we won't get to these two probably, but if you get your own Raspberry Pi and want to mess around with them, there's some really cool projects you can do with both of these. But what I want to focus on today is this set of little pins sticking up. These are the general purpose input-output pins on the Raspberry Pi. And so if you look at your card, you can see that has the names on it, like GPIO2, GPIO3, all those. You have to be able to use this card eventually to understand how to use these pins, because they can get a little confusing. As you can see, there's absolutely no labels on the GPIO pins. So how do we hook up the Pi to begin with? Well, the first thing we want to do is we want to plug it into a power source like this. And when we do, you will see the red power indicator light come on. Now, you'll notice there's this little slot here. There's nothing in that slot. Normally we would put one of these little SD cards, one of these compact SD cards in there. Basically that provides the operating system for the Raspberry Pi. We will get to that eventually. For now, we're just using this device as a simple power source for other components, so we don't need to worry about it for now. Also, when you plug that card in, you'll start to see the little green light flicker, which means information is being passed back and forth through the different components and the SD card is being accessed. So for now, we just see the red light. I'm going to shut it off. It's a good idea to always keep the power off when you don't need it. So this row of pins, the GPIO pins, is represented by this diagram right here. Now, how do you orient it? Well, if the Raspberry Pi is oriented like this, with the Ethernet and USBs down and the video ribbon cable up, that then puts these pins on the right side as you're looking at it. That is the correct orientation for this card. And that's important because if you'll notice, you have a 3.3 volt and a 5 volt power pin on this end, and then you have a ground and then a general purpose D out pin here. If you were to flip it, basically you would be thinking that these were the power pins and this was the ground pin, which is exactly the opposite, and you'd hook up your components and things wouldn't work the way you intend them to. So just remember, the Pi sits like that on the GPIOs. So we're going to focus on this pin, the 5-volt pin, this pin, the ground pin. One thing we're going to learn through this process is that all electronics using direct current have to have a complete circuit. So we have to have a place to create power from, the 5-volt pin, and a place for those electrons to eventually go, the ground. Now, that's a very oversimplified way of electricity working, but that's what we're going to think about today. So what we want to do is we want to put some components in line between this 5-volt pin and this ground pin, such that when we turn the Pi on, it will make those components do something. So I'm going to put the card away, and we're going to remember we're going to be using this 5-volt pin on the top right and this ground pin bottom left. Now we're going to take our solderless breadboard, which, as we learned from a previous video, has a bunch of little wires running in there and allows us to connect different electrical components together. Well, the first thing I want to do is I want to connect power to one of these pins. So I just take my jumper wire, the female end, and I plug it into the 5-volt. And I just pick a row over here. I'm going to pick row 10 on this top side. So what that means is now the electricity will flow once the circuit is complete and the power is turned on. It'll flow through the wire into row 10, and any of these holes in row 10 right here on this side can also access that 5-volt power. So the first thing we want to put in there is a resistor. One thing to always remember is that you never want to use an LED with straight 5-volt power, because the current is too high for the LED to tolerate, and so you always have to put a resistor in. So I'm going to plug this resistor into here, into row 10, like so. And now, oops, didn't want to go in there. There we go. And so now the resistor is connected to the red wire, which is connected to the 5-volt power of the Pi. I'm going to fold it over, and I'm going to plug the other end into row 15. So now row 15 is connected to the resistor, back to the 5-volt wire, back to the Raspberry Pi power supply. Now, resistors can be plugged in either direction. They do not require a certain orientation with regards to polarity. So they're one of these components like a wire where if we flipped it, it would be perfectly fine. One component that is not perfectly fine being flipped is this guy, the light emitting diode. Diodes have a polarity setting, and power must go from one side to the other. In other words, you must connect the power to the correct lead, and you must connect the ground to the correct lead. The LEDs are easy to identify which side to use. If you look at this very closely, you'll notice that one of these wires, one of these leads on this blue LED is longer than the other. That's known as the anode, and that's this one, obviously. The anode is the lead that needs to be connected to the power source. The other wire is known as the cathode, and that's the one that needs to be connected to ground. So we're going to take this long wire and put it into row 15, and we're going to connect the shorter wire into row 16, just like this. There we go. And so if we look at it up close, we can see how these things are all connected. We have our red power supply going to this side of the resistor, which then jumps over to this row, which goes to the anode side of the LED, and then through the LED to the cathode. And of course our objective with an LED is to create energy in the form of light, and so if the electrons flow through the LED and it is within the tolerances of the LED, we will see that happen. Well, the last thing we have to do is we have to complete the circuit. So we're going to take this other jumper wire and we're going to plug it into row 16, which is the same row that the cathode is connected to, and then we're going to go back here to the ground, like so. So we have our red wire connected to power, which then connects to the front end of the resistor, which then connects to the anode of the LED, which then connects to the cathode, and then the brown wire, which goes back to ground. If we did everything right, we should have some light when we turn this on. So I'm going to pull this power supply over, slide this over a little. I'm going to plug the power source in, and when I flip the switch, we should get some light. There we go. That's it. Now we have used the Raspberry Pi to make the light work. go ahead and try this for yourself, and then I'll meet you back at the book.